Good morning, everyone. So,
Morning.
that's set up. So 3 weeks left, y'all. This week, next week, and the week after. Well, I guess technically you have like the 2 days before Thanksgiving, but 3 weeks left. We almost made it. So, excuse me, there's link to pull everywhere. It is now 8 o'clock. Your daily quiz is now up. Whoops. So what is the horizontal asymptote? Whoops, I had to clear responses. So, yep. Now, what is the horizontal asymptote of that rational function? What is the horizontal asymptote of that rational function? Let me share it to screen. So it is x cubed plus x minus 1 all over 3x cubed minus 11x squared minus 13. Looking for the horizontal asymptote. Horizontal asymptote. Get my iPad in here. Can y'all hear that music in the background? I'm not sure if it's picking up. Give me a thumbs up if you can hear the music. All right, good. Oops, not getting picked up. All right, good answers coming in so far. I'm gonna give y'all just one more minute. And then there's not, for horizontal asymptotes, there's not a lot of computational stuff. Let's see how many people we got in. Got 8 now. 18 total. All right, missing 9 responses, 9 people. X cubed minus 11x squared. 13. All right. I'm just missing 3 of y'all. I'm going to give you just 15 more seconds to type in your answer. 15 more seconds. But good answers coming in so far. All right. Locking answers in 5, 3, 2, 1. Locking answers now. All right. Yay, we've got all 18 people here. Awesome. Good job. So, horizontal asymptote, you got to look at the degree of the top, degree of the bottom. So I look at that polynomial that is on top, and I look at it and I say it is a cubic polynomial, degree 3. Polynomial on bottom, also a degree 3. And thus, if the degree on the top and the bottom are the same, we find the leading coefficients for both the top and the bottom, and the horizontal asymptote is the ratio of the leading coefficient. So if I look on the top, the leading coefficient is a nice good old 1. On bottom is a 3. Thus, the horizontal asymptote for this function is y is equal to 1/3. Y is equal to 1/3. But I think very, very, very strong majority of people put that. So good job, everyone. So, any questions? If not, please, like always, give me a thumbs up so I know we can move on. Yeah, I see some people already ready. Thank you, Leah. Janelle as well, Ashley. Okay, now we're starting to get them come through. Cool, cool. Yeah, so since a lot of y'all don't want to turn your cameras on, that is the best form of feedback that I get. So please make sure that you're at least ready to give me a thumbs up reaction. So I'm not just sitting here kind of wondering if I'm talking to actual black screens or not. But, all right, so we're going to move on with today's material. It's about those exponential functions. Today's exponential functions, and then tomorrow is going to be about logarithmic functions. And they're inverses of each other. And part of the reason logarithmic functions were created is to answer questions about exponential functions. But we first need to get a good idea of what exponential functions are. Well, as you saw in the videos, something like 2 to the x, this is a nice, simple exponential function. But instead of our variable being squared, we kind of have it flipped. We have 2 to our variable. So this means we're doubling, we're multiplying by 2. So something like f of 2 would be 2 squared. That's for f of, whoops, I don't know why it switched to blue. F of 3 would be 2 cubed, which would be 8. F of 4 would be 2 to the 4th, 16, and so on. Okay? So we're doubling as we increase the value by 1 for this case, because it's 2 to the x. And what will this be? F of -1, so 2 to the -1. Don't leave it as 2 to the -1. I can rewrite it as something.
0?
Not 0. What do I do with
1/2?
1/2?
Yeah, 1/2. Because remember, if I have that negative exponent, I just make sure I change its position in the fraction. So it's in a numerator, it goes down to the denominator. Something like f of -2. So this would be 2 to the -2, or 1/2 squared, which means it's 1/4. F of -3, which would be 2 to the negative cubed, 1/2 cubed would be 1/8. So we already kind of see just from doing some quick function evaluations that as I go into the negative direction for something like 2 squared, I end up actually getting smaller and smaller and smaller. I'm only getting closer to 0, really. We have this kind of horizontal asymptote for these exponential functions that as I travel to the left, I get closer and closer to 0 without ever reaching it. But as I go to the right, I'm going to see my values just start to skyrocket. This is where, you know, if you always hear exponential growth, this is the type of stuff that they're talking about. It just keeps getting larger and larger and larger. In this case, it always keeps doubling. Now there's one other very, very, very important point. And for this one, it doesn't matter what your exponential function is. In this case, it's 2 to the x, so I'd be looking at 2 to the 0, but anything to the 0th power is always what?
1.
Yeah, anything to the 0th power is always 1. So f of 0 in this case will be 1. Now, when we're mapping, graphing out these functions, they're always going to have a general form. For this case, for 2 to the x, just a nice rough sketch. Goes through the y-intercept. It has a y-intercept of 0, 1, and then as we saw, as it goes to the right, it starts to skyrocket, larger and larger and larger, and as we go to the left, we're going to start getting closer and closer to 0. So that's a nice little rough sketch of what this thing looks like. But really, one of the easiest ways to get graphs is just to plug in a few points and then see what the shape looks like, kind of map them. So all of our exponential functions are going to have shapes like this, either going up as we travel to the right or going up as we travel to the left. But we're not going to worry about the traveling to the left too much. So go back to Poll Everywhere for me. Which of the following is the graph of 2 to the x? Make sure you look at it. Hopefully it's a relatively easy choice. I'm going to remove this though. I'm going to give you back your points. I want you to look at the points, the calculations that we did. Which of the following graphs is the graph of 2 to the x? Oh, let me pull it up for the recording. There we are. No, I want to leave that there. I'll pull it up in a second. That's what I'll do. All right, I'm just going to give you all at most 1 more minute. So make sure you get your responses in. Make sure you look at the graph, see which graph match up with the points that we've calculated on here. All right, I'm going to lock answers here in 15 seconds. I think we got most everyone in, just missing one response. Lone Soldier, waiting on you. Actually 2, we got 19 people now. All right, I'm going to lock answers here in 5, 3, 2, 1. Locking answers now. All right, so 61% of you did get it correct. So that is awesome. So let's look at it. You can see this. I'll unlock it so pictures come through a little bit more clear. But it would be this first graph. I mean, one of the first things I want to look for is that we said for this function f of 0, when I plug in 0, I should go through the point y equals 1. Right? So I got to go through that point 0, 1, which I do see with all of these graphs. Right? But then I have to look at not only the points that I calculated, but also the general behavior. Right? We said the general behavior was that as I make that exponent larger, my y value also gets larger. Right? 2 squared was 4, 2 cubed was 8, 2 to the 4th is 16, and so on. So I should see it increasing. So really it would be one of these top 2 graphs, Let's see if I can zoom out a little bit, get them on the same page. Yeah, almost. So then I just need to go, okay, well, calculate the points, right? We said if I plugged in 1, that would be 2 to the 1, which means the y value should be 2. So this should go through the point 1, 2. And I look at these graphs and say, okay, which one of these 2 goes to the point 1, 2? Well, when x is 1 here, I see the y value is 2. That's a good sign. It's probably this one. And this one, I see that it actually goes through 1, 4. goes through the 0.14. So this can't be for the graph of f of x equals 2 to the x. Let me see if I can write it here. Not good at writing with my mouse. So the 2 points that we said we needed to calculate, just to make sure we match up those graphs. For these two, so we know we need to go through the points. Ooh, that's bad. I want to erase that arrow. That's supposed to be an arrow. Try to keep it on the right, on the white parts. But I know I need to go through the points 0, 1, and I need to go through the points 1, 2. Right? I could also say I need to go through the point, another calculation we did, -1. Oops, not -1, it would be 1/2. Not clear, give me the eraser. So that'd be another point we go through, and again, you see right here, this top graph does. Didn't perfectly circle it, but it does go through that point 1, -1, 1/2. Okay? So that's why it's that top graph. Questions? If not, give me a thumbs up. Yeah, I got Leah. She's ready. Mona Lisa's ready. Chantel's ready. Allie's ready. All right, now we got more people coming through. Awesome. All right, and again, silence is for me, it has to be interpreted as everything is good. I have no issues. So if that's not the case, please, please, please speak up. I know it's early. I know you might not want to be here because it's early. I had to get up an hour earlier because I'm in North Carolina. I'm teaching at 7 a.m. Sucks, but we're here to learn. We got 3 weeks left. We can do this, okay? We got this. All right, so next question is going to be up. You can glance at it if you want to, if you're feeling good. But one of the other things with functions, just like what we have with our quadratic functions and the cubic function, cube root function, etc., we can look at transformations of these graphs, right? We still can shift things vertically. We can shift our graphs horizontally. We can reflect over the x-axis, and we also get one more of reflecting over the y-axis. And we can go into the study of graphing these transformations, but really the easiest thing to do is just plot the points. So just like what we did before when we were trying to get an idea of what the graph of 2 to the x would look like, just calculate a bunch of points, you would plot them, and then we know it's always going to have this general shape of either going up to the right or going up to the left. Okay, so when you look at this next function that we have, I'm going to share screen so we get it in the recording at the beginning before I start writing. Here I'm looking at -4 to the x plus 2. So I want you to look at this, take some time, calculate a few points, and see which of these 4 graphs is matching up with that graph of -4 to the x plus 2. Take your time, show this for the recording. So you can pause if you need to, look at these graphs a little bit more detailed. There we are. All right, looks like we got most people in, but still take your time. I'm going to give you all just another minute and a half maybe. And based on looking at these responses, some of y'all double check yourselves. Right? Redo some calculations. Make sure you got the right answer. All right, I'm looking for 3 more responses. More responses. All right, I'm going to give you all 15 more seconds since we don't want everyone to be waiting. I want to give you all a chance to select. All right, I'm going to lock answers here in 5, 3, 2, 1. Locking answers now. All right, so did we get all 19 in? No, missing 2 now, but that's okay. Most people answered, and most people answered correctly. Again, it was that top graph. It would be the one where you see it slipping down into the right. 76% of y'all got it correct. So let's just try to quickly go through it and then look at, okay, given our points, which of the graphs matched up the best. And then I can also lead y'all through really quickly what it looks like with transformations, just so you see that. But this for us is really the best way to calculate and get an idea of what these graphs will look like. So I already started off one calculation on Zoom, so make sure you come back for me. So the first one I wanted to start was f of 0. Let me maybe center it up a little bit more. That just means I plug 0 into my function. So let's write it up here, f of x, which is -4 to the x plus 2. So then f of 0 would be -4 to the 0th power plus 2. Now I do want to make note of one thing. It can't, yeah, it would probably sound maybe slightly confusing when I say it like this, but that negative is happening after the exponent. If I was raising -4 to the x power, it would look something like this. We would put parentheses around it to say, okay, well then if I put a 2 there, -4 squared, this would be -4 times -4. Whenever we don't have parentheses around that -4 that we see there, we're following PEMDAS strictly. So I do my exponents first, which means I'd be taking 4, raising it to that exponent, and then I multiply that result by a negative. So 4 to the, or negative 4 to the x. This would mean I take -4. Let's say if I square it, this would be -4 times 4. So just a small notation thing that might mess some people up, and just to be aware of, because it is a little tricky. It is tricky. It's one of those things, once you get comfortable with it, it's fine. For the first few times you see it, it's not. Anyway, that's hopefully going to help clear up some calculations, because then when I look at something like -4 to the 0th power, well, that means I calculate the exponent first. So I do 4 to the 0th power, and we said, I'm going to ask you to answer and unmute, anything to the 0th power is always what?
1.
Yeah, thank you, Mona Lisa. Anything to the 0th power is always 1. So this means, I'm going to try to do the calculation in blue right below it. This will be -1 plus 2. Because I calculate that exponent, 4 to the 0th power is 1, and then I'm multiplying it by -1. So I get a -1 plus 2, which gives me a +1. So overall, f of 0, in this case, is still 1. That's a coincidence because we've done some transformations to this graph, not a basic exponential graph, but still goes through that point 0, 1. So that's one thing that I would have to look for. Okay? But now we just do some other calculations. Do things like f of 1. This will be -4 to the first power plus 2, which means that 4 to the first power, 4 to the first power is 4. And if I multiply by -1, this gives me -4 plus 2, or -2. So now I have the points 0, 1, 1, -2. If I did f of 2, this would be -4 squared plus 2. It would be -16 plus 2, or -14, meaning that this one will go through the point to -14. So I just take one step to the right from 1 to 2 on the x-axis, and I make this nice huge leap down on the y-axis because I go from -2 y value to -14. Let's see if I can remember. 4 cubed would be, that would be what, 64? This would be -64 plus 2, or -62. So then this point would be through the 3, -62. So we already see that as I'm traveling to the right, I need to be shooting down the y-axis, right? And pretty quickly too. Now let's see what happens as I travel to the left. I just kind of get some idea of the negative values. So this would be -4 to the -1 plus 2. Well, again, I just kind of rewrite that negative exponent, not kind of, I rewrite that negative exponent. So this would be -1/4 plus 2. I'm trying to save room here. So I'll have a -1/4 plus a 2. And that'll give me 7/8. That'll give me 7/8. And then I would have to continue calculating these, but we'll see kind of a nice little similar pattern to appear. This would be -1/16 plus 2, which would give me a 31/32. Right? Is that right? No, I'm messing something up. My calculations are off. I need more coffee this morning. So if I take 2, let's do it down here. This is what I always want y'all to do. This is something I always preach. If you're unsure, you don't, like, we always try to force ourselves to write in where we're doing the math, doing the calculations, and make it perfect the first time. That almost never happens. Just go off to the side, redo the calculation. So if I take 2 minus 1/4, this would be 8/4 minus 1/4, which means this should be 7/4. So I had the numerator right, but for some reason I wanted the denominator to be an 8. Really, this should be 7/4. Similarly, for -1/16 plus 2, or 2 minus 1/16, this would be 32/16 minus 1/16. So 31/16. There we go. Getting a little bit better. Now I'll do the last one. This is -1/64 plus 2, which will be 64 times 2 is 128. So minus one of those, so 127/64. So now I get 3 more points. Let's see if I can write them in blue below them. -1, 7/4, -2, 31/16, and then -3, 127/64. Just doing some calculations here, but now I see as I'm traveling to the left on the x-axis, as I'm using these negative numbers, I'm actually, again, having this effect of leveling off. I'm getting closer and closer to that value 2, I think 7/4, so that's close to 8/4, which would be 2. 31/16 is also really close to 2. 127/64, again, that's a value really close to 2. And we just see we keep getting closer and closer and closer. So when I'm looking for my graph, I want a graph that looks like it's going through all of these points, right? Going through the point 0, 1, 1, -2, maybe 2, -14 if I can see it. But at least shooting down to the right very quickly as it travels to the right. And then also goes to the points -174, it's -2, 31/16, -3, 127/64. Now, I might not be able to say exactly for those y values, but again, that behavior of it's getting closer and closer to y being 2. And if we go look at all of our graphs, it'll end up being that first one. I'm going to just save the screen for a second in case people are writing. All right. So it's a little blur. Let's unlock so we get better graphs. It would be this first one right here, right? It goes through the point 0, 1. It goes through the point 1, -2. And as we see, we get closer to -2. We're shooting down very quickly. We had probably reached that -14, even though the graph doesn't give it to us here. But then also, more importantly, as we travel to the left, we see the graph leveling off towards 2, right? We see a -1. That looks like it would be about 7/4. -2, it's even closer, right? Even closer to -3, it's even closer than that. We level off, getting closer and closer to the value of 2. Okay? And we see these other graphs, that's not behavior. As we travel to the right, we should be shooting down, which is not this case. We do see it here, but we're not going through the point like even 0, 1. This is through the point 0, -1. We're not leveling off to 2 like we said we should be. We're leveling off to 0. Y being 0. All right, so that's just kind of the basics for graphs, what we want to do. There's some more interesting things there. And like I said, if you wanted to look at this as transformations, we have 2 transformations here, our basic graph, or our parent graph, would come from the function f of x equals 4 to the x, which would have a general shape like this and go through the point 0, 1. I would then work out from that 4 to the x. I see I multiply it by -1, and if we remember correctly, whenever we multiply our function by -1, it reflects over what? It reflects over what? I know I was talking for a little while. Come back to Zoom for me, please. Whenever we multiply our function by -1, it reflects the graph over what axis? Whoops, I saw you unmute here, but I couldn't hear anything. What was that?
X.
Yeah, there we go. Thank you. X. Really quickly, give me a thumbs up if you're still here.
Of course. I'm here.
Well, cool. Yeah, no, I talked for a little bit longer than I usually do, so I wouldn't be surprised if I lost a couple people. That's why I just want to make sure people are here. All right, so yes, whenever we multiply by that -1, we reflect over x-axis. That gives me this f of x is equal to -4 to the x. Then my graph will now be facing downward. I take all of my y values from 4 to the x, multiply them by -1. So now it would look roughly like that. And then the last shift is adding that 2. Well, adding 2 to any graph means we get a vertical shift. We're adding 2 to all the y values, so we shift up. And this is the 0.01, and we're leveling off close to 2. So just, I said I would mention that, and there it is. But again, the easiest way to get graphs for exponential functions is sometimes just plotting the points, and that's all I'm expecting y'all to do, because I don't want to spend time on exponential functions. I want to spend time on what we use them for. So any questions? If not, please give me a thumbs up. And please, please, please ask a question if you got it.
Could you go over it again?
The transformations? Is that what you're asking? Yeah. So whenever you multiply, so I have to first look at this and say, okay, what's kind of like the basic function I'm building off of? And I see here that it's this exponential function for the x. It's not one of those basic functions that we learned previously. Previously, they were like x squared, x cubed, square root of x, cube root of x, what absolute value of x, the line x, and stuff like that. So it changed a little bit what our parent function is, but I still have the same transformations, right? The first thing is I take 4 to the x and multiply it by a -1, right? Still the same transformation that we had before for any graph. If I multiply it by a -1, I reflect it over the x-axis, right? Any positive y values now become negative. Any negative y values become positive. So that's why we see our graph kind of flip over the x-axis. Instead of shooting up and to the right, now it's shooting down and to the right. And then the last thing to account for is adding 2. So we add 2 to all of our y values, which we add 2 after the fact. That is a vertical shift. And that's why we see the entire graph move up by 2. So it's just another way to get the correct graph for our answer through the transformations that we've studied before. Awesome. Thank you, Mona Lisa. And thank you for asking a question. Any others? All right. So exponential functions are used for compound interest. That is one of the uses of it. We'll get into some more later once we get logs, but once we first see exponential functions, this is one of the different uses of them that we'd like to take you through. So if you go to Poll Everywhere, we have a new question. Use the compound interest formula. A is equal to P times 1 plus R over N, N times T to find the accumulated value. So A is the accumulated value of an investment of $8,000 for 6 years at an interest rate of 5.5% compounded monthly. Okay. All those variables, R is the rate, N is the number of times you compound per year, T is the number of time in years, P is the initial amount. Something you should have picked up from the videos. Okay, but take your time. One of the things with these is that you're going to need a calculator. Exponentials aren't going to come out to be nice numbers, or very rarely will come out to be nice numbers. So make sure if you need to, quickly grab your calculator so you can punch this in. And since we're trying to keep this real world, we don't go past cents, right? We don't go past pennies. So whenever you're doing your calculation, we usually like to round to the nearest cent. That's what makes sense. I don't want to deal with a quarter of a penny, right? Some corporation might want to deal with that. Personally, we don't. So go ahead and do this. And really a lot of this at first is just a plug and chug. So make sure you set up the right pieces, punch in your calculator, and figure out the answer. So I'm going to give you all a couple more minutes. I'm going to give y'all just a couple more minutes. Just a couple more minutes. So this is just a plug and chug. I guess let me do this. If you do not have a calculator on hand and that's what you're waiting for, I just sent one in chat. That's what I'm going to use here to show you just the calculation. Desmos.com has a nice little scientific calculator that you can use if you don't have one handy. Or if you want to use it for this homework, let's say. It's a nice little tool for you to have. All right. A couple correct answers so far. I'll log answers here in 20 seconds, though. 20 seconds, because I'm guessing some people aren't responding because they didn't watch the videos and don't know what to do. So, 20 seconds to finish typing in your answer. All right, 5. Well, actually, I'm going to go ahead and lock here in 5, 3, 2, 1. Locking answers now. All right, got a couple in at the last minute. So let's make sure we go through. What are the different pieces? Looks like people don't know. So P, this P right here, represents the initial amount. This is the initial amount of money that we are investing, how much we are putting in. The R is the rate, but the key thing is when we do this calculation, it needs to be a decimal. We want it to be as a decimal. The N is the number of times compounded, but per year. How many times are we going to be gaining interest on this account every year? And then the last one, T, is the time. How long is it going to be in the account? And let's say otherwise, it's always just assume that this is in years. Okay, so now that I have that information, if you didn't get your answer in before, try to see if you can work ahead of me real quick while I'm going through this and see if you can get the right answer. But now I just need to identify, okay, what is my P, what is my R, what's my N, and what's my T? Well, we said we want to invest an initial amount of $8,000. So my P will be 8,000. I said I was going to do it for 6 years, which means it's going to be in that account for 6 years. My T is going to be 6. I have a rate of 5.5%, which means if I convert this to a decimal, this would be 0.055. Remember, if I'm converting from decimal to percentages, we always just move it over 2 spaces, and that's where I'd get the 5.5% from. And the last thing, and sometimes the most challenging thing, is what the value of N is. Well, we said we are compounding it monthly, which means we're doing it every month for every year. Well, how many months are there in a year? How many months are there in a year?
12.
Yeah, 12. So this means that n is going to be 12. So now I just plug this into my formula to get the total amount that I'm going to have after 6 years at this rate, investing 8,000. This will be 8,000. So I'll need another 8 times 1 plus 0.055 all over 12 to the 12 times 6. I'd plug this into my calculator, and you would get this exactly is 11,119.35846. But we said round this to the nearest cent, which means I want to round to the second decimal. So that 5, so look at the next one, I see it's an 8, which means I round up. I don't really have room there, so I'm going to have to do this poorly. I'm going to do it in green above. But the answer would be $11,119.36. That's how much we would have left. Okay. So, and you just make sure you plug it into your calculator correctly. I know a couple people got that. But let's see, I want to show it in, I'm going to give you all a second to finish writing this. 4, 3, 2, 1. Just show you the calculator that I did through that Desmos. As you can see, I just plugged it in as we saw it, my initial amount down here. So 8,000 times 1 plus my rate divided by 12 to the 12 times 6. Plug that in and I would get 11,119.35864, but I round to the second decimal because I'm rounding to cents and dollars. So this would be a 0.36 as my final answer. All right, any quick questions? Not give me a thumbs up, because I see the time. I want to at least get through more. Okay, so I won't do it in poll everywhere, but what if we had, so a similar type of investment. Okay, so 8,000, invest 8,000. And I wanted to do it instead at, have it compound semi-annually. So I still am going to keep my initial setup. I'm investing $8,000. I'm doing it over 6 years at a rate of 0.055%, or a rate of 0.055, or a rate of 5.5%. But now I'm doing my compounding semi-annually, which means it's going to be how many times per year? Semi-annually is how many times per year?
2.
2. No. So in this case, my n would be 2, but then once I have all those variables identified, it's another plug and chug. I'll get 8,000 times 1 plus 0.055 over 2 to the 6 times 2. Plug that in my calculator, round to the nearest cents, etc. Now the last thing that we have is if we compound continuously. So you're always gaining interest no matter what. And the only thing that changes is whenever you see compounding continuously. I'll try to keep it on this screen. Let's see, we're already over time. We use a slightly different formula, though it has a similar look. A is equal to P times e to the RT, where e is that special number, that e to the x function. Right? And you have your calculators all have a special variable for e. I don't think that Desmos does off easy glance, but I know your basic scientific calculators or graphing calculator do have that. But you shouldn't be using a graphing calculator, I don't think. Can't remember what I said for this class. But the idea is the same. You just need to identify your initial amount that you want to invest, your rate that you're doing it, and the time, the amount of time you're investing it, plugging into this formula and solve it. Okay? So this is where we use exponential functions at a basic level. Institutions do use this. Okay? So, any questions? If not, please give me a thumbs up. Oh, I see them slowly coming in. Yeah, there we go. All right, well, if you are feeling good, you're welcome to go. Tomorrow, we're going to talk about logarithmic functions. And they come from a necessity of, let's just say we're trying to use this formula, a equals p times 1 plus r over n dnt. We have an initial amount. We have a goal of what we want to get to. We want to figure out how long we want to put this in there. Well, we don't have the tools yet to say, okay, well, if my variable is up in the exponent, how can I solve for that? And that's where these log functions come in. That's why one of the reasons why we care about log functions. So I just wanted to put that in there for motivation for tomorrow, but you're good to go. Otherwise, please stick around and ask a question. I'm going to go ahead and stop the recording now.